How architecture is going to be important for your performance evaluation. Friends, I was reading Modern Software Engineering by Dave Farley. One very interesting tip I got is going to be possible to measure the performance of the teams. In software, traditionally, it has been very difficult for non-technical management to find out the performance of a team. In software development, it has been very difficult for non-technical management to measure the performance of different teams. According to Dave, this is going to change. He pointed out to another book, Accelerate. In Accelerate, the authors of that book, they did a research, they got a lot of surveys over years, and they came up with 4 metrics to determine the performance of software development team. So now with DevOps measuring a lot of stuff, it's possible for non-technical management to compare the performance of different teams. They found out 4 metrics which are very important to determine the performance of team. First is how less errors you are generating when you make a change to your code. Second is how quickly you can recover your system from error. The third one is how quickly you can move your changes once you committed in the source safe to production. And final is how many deployments you are doing. So these 4 metrics, they can find out is this a high performance team or not. So how the architecture plays in a big picture. The two characteristics of the software architectures are very important: testability and continuous deployment. So these authors, they reviewed different architecture, they reviewed different kind of applications, they reviewed transaction based applications, they reviewed ERP, package software, embedded system, mainframe, newly web-based development projects. They expected high performer teams to be working on the web-based teams. They were surprised that high performance based teams were uniform. It didn't matter. It did not matter whether they were working on embedded system or they were working on monolith applications or microservices application. The important thing was how these applications were loosely coupled to other applications. If a team was able to deploy a system to the production without consulting other team members, could they take design decisions without input from other teams? Could you perform deployment during normal hours with minimum downtime? It didn't matter whether they were working on the packages, commercial off-the-shelf packages, embedded systems, monolith or microservices. The teams which were independent, which were able to deploy software quickly, were high performance teams. In real world, the service oriented architecture or microservices application should be the first one. They should be, authors expect these microservices based architecture where applications are being deployed in the container could be the high performance. It turned out in the real world, a lot of microservices are dependent on other microservices, and generally moving a microservices involves working with other team members and working with a lot of where you need a lot of coordination, cooperation between different teams, and that affect how many deployments you are able to move into the production. The lessons are, if you want to be part of highly productive team, you have to know the architecture good practices. You have to develop loosely coupled system. You have to make sure your application is testable, there's separation of concerns, and you have a continuous integration, it should be easy to deploy. Another tip from these authors is like there's a Conway's law. Your application will be organized in your application architecture will reflect the organization structure of your company. So good practice is, if software is very important for your company, you should organize your company according to the needs of your software architecture. So that way you can make sure your team is highly productive. You may say, okay, you don't have DevOps. Why you should learn about architecture, about these good practices, making system like loosely coupled, testable, and quickly deployable. If you have an ambition to work in the big company and you want to succeed, the chances are you're going to be evaluated on these metrics, and unless you are following some good practices, unless you are following good architectural practices, good agile engineering practices, it could affect your performance. So friends, this is a great book. I will be reviewing more about this. I will be reviewing more chapters, more points, I will be reviewing more findings from this book. So friends, thanks for watching this video. If you like this video, watch my other videos in my application architecture blog. Also like it, share it, and subscribe to my channel for your regular updates. Connect with me on LinkedIn and Twitter, especially LinkedIn if you like small summaries of the video. I will be posting a lot of small summaries of the video on LinkedIn. Thanks again.